Hello students, welcome back. I just added one more exercise problem at the end of section 3. It's this problem here. Please stop the playback and read through the problem set. The following data table shows the daily closing prices of Dow Jones Industrial Average, S&P 500 Index, and Nasdaq Composite Index for 1 month. And here's the data set. And that's not really important for our purpose. Here's a summary version, and that's all we need. The means, standard deviations, and the correlations. Basically, we have this Dow Jones Industrial Average. That's blue. And S&P 500 Index. That's green. And Nasdaq Composite Index. And that's red. So basically what we have here is a correlation between Dow and S&P 500. And S&P 500 and Nasdaq. Oh, wrong color here. So this one is not applicable. And Dow and Nasdaq. And this one here is not applicable. Okay, it's a little bit easier this way. Now, let us use the linear regression to find the best point estimate of S&P 500 index, the second column, when the Dow Jones Industrial Average is about 28,000. So, we want to find the green S&P 500 when we know that Dow Jones blue is about 28,000. That's a problem. By the way, the purpose of this problem is mathematical exercise to practice the use of linear regression formula. This is not an investment advice. I want to make sure of that. Okay, how do we approach this problem? Method number 1 is slope point method. And here's a slope point equation of the line. Here's a slope. And then this line runs through the average point, x bar, y bar. X bar and y bar. Now what's x? Known quantity is x. The problem says Dow Jones is 28,000. So that's x, which I just highlighted in blue. And y is S&P 500, and that's a known, and that's something we have to find out. Okay, we have this regression formula, and we have to put in all those numbers in. So x is Dow, and y is S&P 500. X is blue, and y is green. Put in all these numbers. R, the correlation coefficient, is correlation between Dow and S&P. 0.917. Of course, these two are the same. And this one, not applicable because in this pair, Dow and S&P, Nasdaq is irrelevant. So we have 0.917 that goes over here. And then how about the standard deviation? SY is this one, and we have 252.92 right here, and then 2237.89 right there, and so on and so forth. Basically, here's a computation. Does it make sense? Let's see. This one is green, blue, we know blue, we know blue, and then that's green. And then run your calculation, and you're going to get this rounding about 3,260, or you can even write 3,300 if you prefer that way. Let's see, that's green. Blue, 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 green. Here we go. Okay. Next, let's work on the same problem using the slope-intercept method. So here's the equation of the line. This is the slope, and this is the y-intercept. And how do we get that? Here's the slope computation, and after calculating this, you can find out the y-intercept by this formula here. And then put those in, you can finally do your regression. Basically, this is a three-step process. Idea is the same otherwise. We know Dow Jones, that's blue, and we don't know S&P 500, that's green. So we know blue, and we want to find out green. That's the idea. Okay, how does it go? Well, here is B1 computation. Plug in all those numbers in. And then here is B0 computation. Again, plug in all those numbers in. And then when those two are done, put everything into the slope-intercept equation of the line, put all those numbers in, and run your calculation. It's a three-step process. And if I do some color coding here, oh, never mind about color coding. We already went through that. Okay, there are two methods here, and I prefer solution number 1, slope point equation method, but our textbook prefers the second method. One more time. Part B, use the linear regression to find the best point estimate of Nasdaq Composite Index, the third column. So that's what we want to find out. When S&P 500 index, the second is about 3,300. So we know green, and we want to find out red. That's the idea. So which is X and which is Y? What color is X and what color is Y? This time we are not considering Dow at all, so that's out of the picture. And which one do we know and which one do we want to find out? Here we go. We know S&P 500, and we're going to find out Nasdaq. So that's the idea. And what numbers do we put in? Well, SX, that's coming from the known variable, so it's coming from S&P 500. And unknown is Y, and that's Nasdaq. X is known, X bar is known there, and Y is unknown, so that's the Nasdaq part. So put all those numbers in and run your calculation. Let's keep all these color coding here. See, this one is coming from Y, Nasdaq, and this is coming from green, Dow Jones. Not Dow Jones, excuse me, S&P 500. And then in the end, we have that computation. So the formula is the same, and all you have to do is to make your decision. What is X, what is Y? And then putting all those numbers in and running your calculation is easy. If you don't understand what's X and what's Y, X is input and Y is output. If you don't understand it, you can't get it done. Okay, that was one-step process. And here is three-step process. textbook's method. Excuse me. This is wrong. Okay, S&P is known, and then we're going to find that Nasdaq. Okay, and then here's a three-step process. Slope is B1, and intercept is this formula, y-intercept I mean, and then here's the slope-intercept equation of the line, the regression line, and here are the computations. B1 formula here, and run your calculation. Done. Here's B0 formula. So put on all these numbers and run your calculation. And here we have to use B1 computation you just did in the previous step. Now we have B1 and B0. Put everything into the slope-intercept equation of the line. And here's the computation. And of course, not surprisingly, we got the same answer as before. Now, can you do the third problem here? Use a linear regression to find the best point estimate of Dow Jones Industrial Average, the first column. When the Nasdaq Composite Index, third column, is given as 8,500. So, Nasdaq is known, and then Dow is something we have to find out. So, which is X and which is Y? Here's my question. What is X and what is Y? And once you figure those out, you can put all those numbers in right place, and that's going to be it. Or you can use the three-step process. Same idea, which is X, which is Y, and then put all those numbers in for the first formula for B1, for the second formula for B0, and for the third formula to get the final answer after getting B1 and B0 from the previous steps. I'm going to leave the details to students. And I'll say finally, the linear regression part is done. I didn't draw the picture here, the scatter diagram here, because I'm going to need 3 pairwise pictures. And with this data set, yes, it is possible because it came from my MS Excel, but in order to get it done here in Mathematica, I have to type in all those data again for Mathematica and then run it. Too tedious, so I didn't do that. Still, I hope you found out everything that you need to know about what's X and what's Y. Basically, X is input and Y is output. X is known and Y is something you want to find out. And that depends upon what the problem is and what you want to find out. So here we went through an example problem that XY changes multiple times. Okay, that's it for section 3.